Let's see if we know what polynomials even are. Let's break the word down. What's the first part of the word you probably recognize? Poly. And what does poly mean? Very good. What are some words that start with poly? Polygon. Polyspot? What does that mean? That means many spots. I believe you. It applies mostly to cheetahs and leopards. Many spots. I'm making that joke. I'm not good at it. Okay, so poly means many. There are a lot of words that start with that. What about the second half of the word, though? Many what? Many nomials? So why do you say numbers? Okay, not a bad swing. It's a, you're right. So numbers essentially is what we're talking about. Really, the way I remember this is through a different word. And specifically what we're going to say here is many terms. And the way I remember it, I don't know that this is exactly where the word comes from, but when I see gnome in the middle of a word, it's a Latin root. I think of, y'all remember how to say name in Spanish? Nombre. And so there are many names. A term is like something that you call something, right? Like, what's the term for this thing? Oh, wait, it's a pencil. Okay, so there are many terms here. Many different little pieces of information. So an example of a polynomial. It's just going to be a bunch of terms. And usually it's going to be terms with x raised to some power. So like 12x squared minus 3x plus 2. That's a polynomial. And recall also that these pieces that are added or subtracted together are called what? Yeah, terms. So a polynomial is something with many terms. Pieces that are added together. And those terms are going to have x raised to some power. So I'll say x to the n. Each term is going to have x raised to some power. I'll say it again. Let me rewrite that. So every term is going to have x raised to some power. So in the first term, you notice we have x squared, right? And what power is x raised to in the second term? Yeah, the first. It's x to the first power. What number is x raised to in the third term?
0.
Good. That's x to the 0 power. X multiplied together 0 times. Okay, so that's what a polynomial looks like. It's going to have x raised to some power in each term. And usually it's going to have more than one term. Now, even if it has one term, really we could call that a polynomial still. It's a special type. There's only one term. So it's a monomial. Good, somebody said it. What if there are two terms? A binomial, 3 terms. A trinomial, 4 terms. Quadrinomial? I don't know. I have no idea, honestly. I'm sure there's a word for it. Okay, but this is the type of thing we're going to be dealing with a lot in the near future. And so I want to review some algebra skills that are going to be involved with dealing with polynomials. Now, one thing you might that might jump to your mind when you see especially a trinomial like this one with x squared, what did you usually have to do to solve an equation that involves one of those? You said it with such pain, inner pain. Yes, factoring. That's one thing that we want to be able to do with these. But factoring is only useful in certain situations. In other situations, we might actually want to expand. And we'll talk about the difference between these two things. So, for instance, factoring. Now we've done a lot of factoring in here, although we haven't done a lot of the trinomial type of factoring that you might remember, that you might immediately associate with the word. So factoring, of course, just means we're going to write the expression I'm going to say as multiples, things that are multiplied. Like that. When we expand, we're going to write the expression as a bunch of terms. Things that are added together. Something plus something else plus something else plus something else. Okay? So factors are multiplied together, terms added together. Important math words. Alright. So let's try some examples. I'll do a couple, and then basically I'm going to give you some examples, and I'm going to let you give some time just to practice this. These are just some important skills. There's nothing new here that you haven't seen before, but maybe something you're out of practice with. So let's start by trying some factoring. So let's say I have, and I'm going to put it in this column. That means I want to factor it. Let's say I have something like 4xy plus 2y. Now the first thing I want to point out, this is not an equation. There's no equal sign. There's another important math word to understand. It's not an equation. We're not solving for anything. We just want to factor it. We want to split it up into something multiplied by something else. So the first thing we always want to look for when we're factoring stuff are common factors. So are there any common factors between these two terms? Jessica says yes. What are they, Jessica? Okay, so y would be one of the factors, and so would 2 that are shared. And what would be left over? Good. See? You do know how to factor. So both of these terms have a 2 and a y as factors. So we're going to take those common factors and move them outside. Yes. Yes. Uh-huh. So there is one factor. There is another factor. So I've split it up into two things that are multiplied together. Okay, so that's the simplest kind of factoring. You want to look for common factors. And that should always be the first thing that you look for. Okay. Let's try another. Yes. Like that. Okay. Let's try another. Okay, so here's another list of terms, and what we want to do, because I wrote it in the left-hand column, is try and factor it. Now, the first thing we always want to look for are common factors. So are there any common factors? X is a common factor, yes. And so the first thing I'm going to do is remove that common factor, just like we did on the problem before. So x times something, and what's going to be left over? Good. It's all going so well. Now, I've got an x, so obviously I can't factor this x, right? But let's look at this inside part. So you notice there is an x squared in there. Okay. So if it has an exponent of 2 or larger, we're going to try and factor it more. So we're going to keep trying. I'll say keep trying. So we've got x to the second power right there. That means we need to keep trying. Can we factor this inside part where we have an x squared? So here's where we have a trinomial. So this is the part that might trip us up from time to time. Let's see if we remember how to do this. So we've got a trinomial, and we want to write that as two binomials. And I'm not going to make you do any like super complicated factoring like this. In fact, I'll give you some tricks that can really make it a lot easier. But this is a simple one. So let me work you through this one and see if you remember how to do these this basic factoring. So essentially what we're doing is foiling in reverse. So I want to know what expressions would go here so that if I foiled them together, I would get that. So I know these first two terms are going to have to multiply to get x squared. Agreed? So what would that be? Yeah, x and x. Those are going to multiply together to get the x squared. Now, this middle term's a little bit more complicated. I'm not sure what's going to go there yet. But I know these last two terms, whatever numbers I pick to go in these last two spots for these binomials, have to multiply together to get not just 3, but negative 3. So it could be 3 and negative 1. It could be negative 1 and 3. That's the same thing. It could be negative 3 and positive 1. Okay, so we just have to figure out which pair is going to work. Would it be negative 3 and positive 1, or would it be positive 3 and negative 1? So the way we're going to figure that out is just by trial and error. Okay, so let's see. What if it was x minus 3 and x plus 1? So I would get x squared, remember how to FOIL, then plus x, and then minus 3x, and then minus 3. Okay, so that's what I would get if I used a minus 3 and a positive 1. Does that work? What would I get as my middle term there? Yeah, that would give me a negative 2x. I want a positive 2x. Okay, so that's not right. It should be. Let's try it, because that's the only other option. So that would be x squared, of course, and then the middle terms, we would get, for the outsides, negative x, and then for the insides, a positive 3x. And it's always those two terms that are going to combine, the outsides and the insides. And they combine, in this case, to give you positive 2x. So that works. So there's our winning combination. So it's a positive 3 and a negative 1. Would it matter if I wrote them in the other order? A minus 1 and a plus 3? No, not in this case. Because these both have the same, they both start with just x. So I can switch them around. Brittany? Right. So if it was like a 2x and then a 1x, then it would matter where you put the minus 3 and the positive 1, because that would change what gets multiplied together. Yes. Alright. So let's try one more. This time, let's do y to the fourth minus y cubed minus 6y squared. So we're going to try and factor it again. What's the first thing we should always look for when we factor? Common factor. Well, if there were like terms, then yes, that would be a good starting place. So there are no like terms. So let's look for common factors. So what can I take out? What's a common factor? Squared, and then left over I'm going to have y squared minus y minus 6. It's a quadratic. So I'm going to try and factor it just like we did on the last one. So let's see if we can do that. I know I'm going to have a y and a y, and my last two numbers have to multiply to get negative 6. So on a simple one like this, I'm just going to try it in my head. What combinations that multiply to get negative 6 would work here? A negative 3 and a positive 2, or a positive 3 and a negative 2? I think I heard a negative 3 and a positive 2. Let's try that. Okay, so what would y times y be? My first two terms. Yeah, that's y squared. So I'm going to put an f. That's where my first two terms, that's what my first two terms should multiply together to get. I know that my last two terms are going to multiply to get this negative 6. That's the L in FOIL. But then it's these middle two terms that are the wild cards. So what's going to happen in the middle? So I've got a 2y and then a negative 3y. Those combine to give me negative y. So this is my outside two terms plus my inside two terms. The oi, I like to call it, from the FOIL. So here's your f, here's your L. It's the oi that you have to pay attention to. So these are, this is the factored form right here. Now, how do I know I can stop? How do I know I'm done? Yeah, I'm going to look at the exponents. What's the exponent on this y? A 1. So that's as much as I can factor. It's linear. What's the exponent on this y? 1. Now, this is y squared, but it's just y squared, right? So really, it's just y times y. It's already factored, because that's what y squared means. If it was y squared minus 1 or something like that, if this had other terms attached to it, we would have to try and factor that as well. So we want to reduce it down to linear terms where we can. I'm sorry, linear factors. Y minus 3, y plus 2. Linear meaning the variable is raised to the first power. Okay. Let's try the opposite. Let's try expanding. So this time, we're going to start with some things that are, say, factored, some things that are multiplied together, and we're going to try and write it out as a list of terms. So basically, we want to actually do the multiplication and see what we get. So here's an example. What about 2y times 2x plus 1? If I wanted to expand that, I want to do all the multiplication that it says there and write it, my answer as a list of terms. So individual pieces that are added together. Right now I have factors. So what should I do? Distribute. And what do I get when I distribute? 4xy plus 2y. Look familiar? Yeah. It's the exact opposite of what we did on the first example before, right? So these processes are essentially, we might call them inverses of each other, right? So whatever we did over here, we're going to undo it over there. So expanding gives us a list of terms, and they're useful in different situations. Sometimes we want to have it factored. That's when we're trying to find like zeros, things like that, when we're trying to solve an equation. When we expand it, we're going to try, that's going to help us see what properties the equation has, like if we're trying to graph it, something like that, the end behavior, how many zeros it should have, etc., etc. Okay. Let's try another one. This time I'm not just going to steal the problem from before. Actually I am. Let's expand this. Now I know what my answer should be, but do I know how to get it? So here I have three things multiplied together. And I want you to remember one property of multiplication. That's the commutative property. It doesn't matter what order I multiply these three things together in. I can pick any two, multiply them together first, and then multiply whatever that result is by the last thing. So I've got three things multiplied. The order in which I do that doesn't matter. Which two do you want to multiply together first? What? The two with parentheses right there? Okay. And so we're going to distribute, although in this case it's usually given a special name. What's that special name? Yeah. So here we're going to FOIL it. So again, I'm saving multiplying by this x for later. And whatever I do to multiply these two things together is going to go in this set of parentheses. It still needs to get multiplied by x. So let's try this. Now I know what I should get because it's over here, but let's FOIL it out. So I'm going to do the first two terms, x times x, x squared. Then I'm going to do the outside terms. That's the x and the negative 1, so that's minus x. Then I'm going to do the inside terms. That's the 3 and the x, so that's 3x. And in between each, I'm adding. Or if it ends up negative, subtracting. So 3 times. That was the outside two terms. So that's the x times the negative 1. And I'm going to put a minus because it ends up negative. Mm-hmm. Yeah, that was the first two terms. So the first two terms of the two binomials that I'm multiplying together. So the x times the x, x squared. And then outside, negative x, inside 3x, and then my last two terms, 3 times negative 1 is negative 3. And usually, not always, some of these terms are going to combine. So at any point during the process when I have like terms, it's going to help me out to combine them. So what are my like terms there? Those two. Okay, so then x squared, and that's going to be what? Plus 2x minus 3. Okay, so we multiplied these two things together. We could have started by multiplying any other two parts together, but those are the ones we picked. It doesn't matter where we start. But we still need to multiply that result by x. So what's going to happen is a lot of you are going to leave this x off. You're going to say, ooh, I'm going to multiply those two things together. And you're just going to start doing it. And then you're going to forget about this little x over here, still waiting its turn. So let's give the x its turn. How do I multiply this x by this list of terms? Yeah, we're going to distribute it. And that's x cubed plus 2x squared minus 3x. Now we have a list of terms. Term, term, term. There are no parentheses with stuff multiplied by them. Those are factors. These are simply terms. So that's when we can stop, when we just have a bunch of terms. So it's a polynomial, in other words. We have many terms. Okay. Let's try one more. See if I can make it more complicated. Which is my favorite thing to do. Okay. I'll see if I can trick you. Test your algebra skills. Okay, so this is factored. I want you to expand it, to write it as a list of terms. This would be useful if we're trying to solve the equation. Writing it as a list of terms would be useful in other situations. Let's see if we can write this as a list of terms. You want to take a second to try it? Yeah, you do. Give it a try. Let's see how far you can get. And just so we're all doing the same thing, let's go ahead and multiply these first two together. That way when we talk about it, we'll all be on the same page. So start by multiplying these two together, the x plus 1 and the x minus 4, although it doesn't actually matter which two you do. And don't forget about the x plus 2. Yep, I want you to expand it all the way out. Hint, that's going to take some room. Alright, I'm seeing good things. That makes me feel good. So what do we get when we FOIL the x plus 1 and the x minus 4? I know I'm going to get an x squared. I know I'm going to get a minus 4 at the end. And it's going to help us to go ahead and combine these two middle terms. So the middle terms would be negative 4x and a positive x. But they're always going to combine. What does that give me? Yeah, negative 3x. That just gives me one less term to deal with on this next step. Now, I don't know if I've talked trash about foiling yet. Probably not, because we use it, because that's the way you learn how to do stuff. But how does that apply here? Are we going to FOIL? So are we using some other method? We're going to use the distributive property. So how so, Kat? Would you like to explain? Okay. So I'm going to distribute the x, and then distribute the 2. Yeah. And really, that's the exact same thing you do in the FOIL method. I'm not sure why. I'm not sure why you learned this special method called a FOIL. And then you can't FOIL this, but it's the same thing. It's just distribution. FOILing is just distributing. We just give it a special name. We're going to do the same thing here. So the way I think about it, just distribute the terms one at a time. And it doesn't matter which side you do it from either. So distribute the terms one at a time. That's how you multiply polynomials together. And really, that's what you do when you FOIL also. You take the first one, you multiply it by, you take the x, you multiply it by both of these. Then you take the 1 and you multiply it by both of those. And that's FOILing. It's the FOIL method. This seems simpler. But who am I to judge? Okay. So let's try that. So x times x squared, x cubed, x times negative 3x, negative 3x squared, and then x times negative 4, negative 4x. So there I distributed the x to each of these terms. Now I'm going to distribute the 2. 2 times x squared. It's positive, so I'll put a plus 2x squared. Then 2 times negative 3x would be minus 6x. And then 2 times negative 4 is going to be minus 8. And so you're going to have addition or subtraction in between each of those products that you get when you distribute. Now we just want to see if there are any like terms. So here's an x cubed. Does the x cubed have any buddies? Any other x cubes out there? No? It's a lonely existence for x cubed. What about 3x squared? Does it have any friends? Okay, so I'll put circles around these squared. So 3x squared and 2x squared, they're friends. So what do they combine to give you? Negative x squared. And remember, it's only the coefficients that change when we combine terms, not the exponents. Are there any x's? I'll put boxes around them. So there's 4x, and there's negative 6x. And don't forget about your negative signs. Those combine to give you what? Negative 10x. And then we've taken care of everything except this last minus 8. Does it have any other non-x terms? No. That's sad too. Minus 8. Are we done? Or is there more we need to do? How do we know we're done? Yeah, we just wrote it as a list of terms. There are no parentheses, no things multiplied together. It's just a list of terms. Okay. So these are the basic algebra skills we're going to use for polynomials. It seems like most of us are pretty good with expanding things. Factoring can be a little bit trickier. So I'm going to give you a few practice problems. We'll see how you do. And we'll go from there. So we'll make an expand column and a factor column. I might have switched the order. It shouldn't matter. So give these a try. And I'll see if I can give you some that are a little bit tricky. Not all of them. You know, some easy ones to warm you up. Then some tricky ones at the end. Okay, so we'll try and expand those. And by we, I mean you. Okay. Let's work on these for a few minutes. Give these a shot. If you can do this stuff, you'll be in good shape as you go to the next unit. If you can't, then you'll be in bad shape. But you can practice. That's the nice thing about math.